So in today's section at 4.6, we're going to discuss mixed numbers and improper fractions. In your first example, there are three different kinds of fractions. You can have an example 1 7/8, example 2 10/3, and example 3 2 1/2. Number 2, a fraction whose numerator is less than its denominator is called a proper fraction. So in example 1, you have 7/8. That is a proper fraction. In example 2, you have 5/6. That is a proper fraction. Number 3, a fraction whose numerator is greater than or equal to its denominator is called an improper fraction. In example 1, you have 10/3. In example 2, you have 4/4. And number 4, a mixed number has a whole number and part, and a fraction part. So in example 1, we have 2 1/2. In example 2, we have 4 1/3. Now, in example 5, we're given examples of mixed numbers. Mixed numbers can be written as improper fractions. So if you have 2 1/2, it is equal to 5/2. Because you multiply the whole 2 times the denominator, 2, which is 4, plus the 1 that you have left over, so you have 5/2. So 2 1/2 is equal to 5/2. So when you have a mixed number, such as in 5, you check the denominator to see what it is divided into. So in this example, we have 2 wholes, and they're going to be divided into 2. And then I have another half. So I have 1, 2, 3, 4, 5 halves. In number 6, we're going to be asked to write the mixed number as an improper fraction. So in A, we have 4 1/3. 4 1/3. Write that as an improper fraction. You should have had 13/3. In B, you've been given a mixed number as 3 6/7. Write that as an improper fraction. You should have gotten 27/7. C, you have 10 4/13. 134/13, because 10 times 13 is 130, plus your 4 is 134/13. In D, we have 3 4/16. So in D, I have 52/16. In E, I have 5 6/17. So in E, 5 6/17 is equal to 91/17. Let me say, for example, in E, you have 5 wholes. That's your whole number. Then you have 6/17, which is part of a whole. So you have 5 whole pies that are divided into 17 pieces. So 5 times 17 plus your 6 that you have left over is 91, and 91/17 is your improper fraction. Okay, now in number 7, we have improper fractions can be written as mixed numbers. So now in that example, we have 10/3. 10/3 is a division problem. You will notice that as you continue on in math. 10/3 in a fraction form is also a division problem. So 10 divided by 3, 3 goes in there 3 whole times with 1 left over. So 10 divided by 3 is 3 1/3. So consider each of these when you're told to write the improper fraction as a mixed number. Divide. How many times it goes in their whole is your whole number, and what you have left over is your fraction. So, in number 8, you have 25 over 2. That can be said as 25 divided by 2. Good. So 2 goes into 25, 12 whole times, with 1 left over, so it's 12 and 1/2. You keep the same denominator. Okay, and B, you have 16 fourths. 16 divided by 4, which is 4. And C, we have 103 twelfths. 103 divided by 12. So 12 goes into there 8 whole times with 7 left over. Oops. Okay, I have 184 sevenths. So that would be 184 divided by 7. 26 and 2 sevenths. E, 98 thirds. And so 98 thirds is equal to 32 and 2 thirds. Now we're going to compare. In number 9, we're going to compare the fractions. There are several different ways that you can do it, but one way that we're going to do in solving it is to change them both, make sure that they're both mixed numbers. So we're going to change 19 thirds to a mixed number. So I'm going to change this to 6 and 1/3. Now, as I'm comparing these two fractions, I'm going to look at the whole number. They both have a 6 in the whole number, so I will need to compare the fractions. So now I'm going to compare 1/3 and 2 sevenths. Now, there are some times when you cannot tell by looking at them. So let me give you a strategy. If you're not sure by looking at two fractions, which is the largest, you can do the method of finding their least common denominator to compare to see which is the larger of the two. So I have 7 21st compared to 6 over 21. So 1/3 is going to be larger than 2 sevenths. So 6 and 1/3 is going to be larger. It's going to be greater than 6 and 2 sevenths. Another way you can think of it is you have a pie. If you're going to compare 1/3 and 2 sevenths, your pie is cut into three pieces, and you eat one of those pieces. Or you have a pie that's cut into 2 sevenths. Excuse me, your pie that's cut into 7 pieces, and you eat 2 of those pieces. Which piece is going to be larger, your 1/3 or your 2 out of 7ths? Your 1/3 will be a larger piece that you'll be eating. So that's another way you can think about how to compare it. Okay, so in B, let's change B to a mixed number. So in B, this changes to 2 and 5 6, and we're comparing 5 6 to 1/4 because our whole number is the same. So hopefully that you can look and tell that 5 6 is going to be greater than 1/4. So 2 and 5 6 is going to be greater than 2 and 1/4. Now let's change C. Let's change our 8/3 to a mixed number. So now 8/3 is the same as 2 and 2/3, and we're comparing that to 2 and 2/3, and we will have equals for that one. D, 29 fifths. Let's change that to a mixed number. So now we're going to compare 5 and 4 fifths to 6 and 3 fifths. 5 and 4 fifths is going to be less than 6 and 3 fifths. Now, you will be given some fractions that they're going to ask you to order from least to greatest. So in these, in A, it looks like every one is in an improper fraction. So what we did was we changed each one of these improper to a mixed number. Now we can compare the whole numbers to see if that helps us put them in fractions from least to greatest. Okay, so this one was relatively simple because the whole numbers were all different. So you put them in order from least to greatest in their original format. So let's look at B. Notice that we have some that are in mixed numbers, some that are in improper. So let's change the two that are in improper to a mixed number. So we have changed each of those fractions to be a mixed number. So we're going to look at these now and start comparing. Now, we're going from least to greatest. So you already know which one your greatest one is. 12 and 2/3 is going to be your greatest, so you can go ahead and put that down as your greatest. And so now we're going to be comparing 9 and 4/9, 9 and 11/20, 9 and 21/40, and 9 and 1/2. So some of these you can look at to determine which is the smallest. Some of them are half, some of them are a little less than half, and some of them I'm not sure which is the greater of the two. So 9 and 4/9 is less than half, because half of 9 is 4.5. So 9 and 4/9 is going to be the smallest, because I have a 9.5 here, which is going to be right at half. So if I've got, this is going to be my greatest, so that's going to be number 5. This is going to be number 1 because that's less than half. This is half, so it's going to be 2. It's going to be number 2 in order from least to greatest. So I just compared the fractions by looking at them. I compared 4/9 and 1/2, knowing that 4/9 is going to be less than 1/2, so it will come first. But now I need to compare 9 and 11/20 and 9 and 21/40. If you can't tell by looking, you can find a what to compare those two, class? Least common denominator. And their least common denominator would be 40. So if I wanted to change this fraction right here, it would be 9 and 22/40. So now you can see of those two fractions, which is the smaller. So as we just got through saying, our first fraction is going to be 9 and 4/9. Our second fraction is 9.5, which is 19/2, because it's in the original format. Then we just determined our third one by finding a least common multiple, which is 9 and 21/40. Then the next one, of course, is going to be 9 and 11/20. And our last one that we already knew just by looking at it was 38/3. So the first steps that we did was we put them all in mixed number. Then we chose the ones that we knew were going to be the least, ones that we knew that were going to be the greatest just by looking at them. And then if we still couldn't determine which one came next, we found the least common denominator for them. Now, here's a word problem. You're going to have the distance in miles that 4 students travel to trick or treat are listed below. Order the distances from least to greatest. I'm going to pause the video and let you guys work this out. Remember, we're going from least to greatest. So notice that we changed 11/6 to 1 and 5/6. Then we changed 29/16 to 1 and 13/16. Now, they each have 1 as a whole number, so we're going to need to compare the fractions. So you're going to be comparing 3/4, 5/6, 7/8, and 13/16. Now I'm noticing that they each are close to a whole. 3 out of 4 is close to a whole, 5 out of 6, 7 out of 8, and 13 out of 16. Now again, some of you can tell by looking, but if you're not sure how to look, you can find the least common denominator for those four numbers. So 1 3/4, the equivalent fraction to that would be 1 36 over 48. So notice that in each of the rest of them, we change them to equivalent fractions. Now we can compare the numerators, but we need to put them in the original format. So the smallest one is going to be 1 36 over 48, but we need to put it back in the original problem, which is going to be 1 3/4. So I would mark through it because I've already used that one. The next one is going to be 1 39 over 48, which the original problem is, what did I do wrong here? So my enter key is wrong that I have up here. Shouldn't the next one be 29 over 16? So let's put this back up and let's list it. So my smallest is going to be 1 3/4. My next one is going to be 29 over 16. My next one is going to be 11/6. And then my last one, because it is the greatest one, is 1 7/8. Now some of you could tell by looking at the fractions, 3/4, 5 6, 7/8, and 13 over 16, which is the greatest. But if you come to a time where you're not exactly sure, find a least common denominator for them to compare them, but put them back in their original format.